defining a structural entity. Information such as cover to reinforcement, trial sizes of reinforcement, sizes of shear reinforcement, sizes of flexural reinforcement, and so on. The characteristic material strength of steel, characteristic material of concrete. These are the crucial engineering technical information that will be specified in this design parameter, which STAAD will use inherently to design your structure after analyzing the structure to reveal the internal stresses or the internal moments, shear forces, and so on. So the first one is asking us, okay, select brace member. What does this mean? This is asking you on your structure. Now look at your structure. What STAAD wants you to do is to select the columns that are braced in either one direction or in two directions or are completely unbraced. How do you know? Simple. Go to on each floor you have the architectural drawing. If I superimpose, okay, let's do something. Let's look at something. Okay. Okay, if I reveal this is the second floor structure. Let's look at this architectural layout. Good. On the architectural layout, you can see the columns that are braced. This column, for example, is braced by a wall effectively in this direction and on this direction, but it's not braced in this direction. So this column can be said to be braced in one. See, look at the instructions STAAD is asking you. Is the column braced in both directions, or in the one direction local Z, or in one direction in the local Z? Sorry, previous one local Y, this Z, or is not braced at all in both directions. So this is what we refer to as the local Y. So depending on the local coordinate system, this column, the axis pointing to your direction, your direction of view, you viewing this video, the axis that is normal to your screen is what you call the local X axis. And then one of the perpendicular axes that are in this direction is the Z or Y, depending on your model orientation. So if this column, for example, we're looking at this, if this column has a wall here and a wall there, the column is effectively braced in one direction, but it's not braced in this direction. So you can tell STAAD that this column, you will select this column and say, oh, this column is braced in one direction. And this, for example, is not braced at all because you just have beam, you don't have any wall around that, and so on. So typically you would select the columns that are braced, tell STAAD. So what you do is to take this, add. If you have columns that are braced in one direction, you tick 0, you add. If it's unbraced, you tick 3, you add. If it's in one direction, you tick 1, you add. No. So you add those specifications and then you assign it to the corresponding columns that are either braced in 1, 2, or unbraced. But for the purpose of this analysis, we are going to assume a critical situation that all the columns are completely unbraced. So you say 3 and add. The next thing, you go to clear. So clear is the distance from the surface of the member to the edge of main reinforcement. What does this mean? Let's explain what this means. What does this mean? The distance from the surface, let's look at what this means. We're going to use a typical structural detail to explain what this means. Okay, if you look at this structural detail from a previous project, what STAAD is asking you is It says distance from the edge, from the surface of the member to the edge of the main reinforcement. So it is just asking you for this dimension. So you remember you have your cover to reinforcement is distance from here to the bottom of your main reinforcement. So typically what STAAD is asking you is the cover to the reinforcement. Okay, so it is not necessarily the cover, because you know that the cover is the distance from the bottom to the edge of the stirrup, but STAAD is asking you the distance from here to the bottom of the reinforcement, and not the bottom of your stirrup. So what you will do is simple. For your slab, for the beams, we are using a cover to cater for 1 hour fire resistance in compliance with the code. The cover to our reinforcement, we are providing a cover of 25 millimeters. Therefore, and then we intend to use a stirrup size of 10 millimeters. That means the distance should be 25 plus 10. That's 35 millimeters, so you put that there. So this is for this pertains to the columns and the beams. Okay, and depth of cross section to be used in design. So we are using the defined depth, so that's okay. You go to ELY. Great. ELY is the slenderness ratio factor for buckling about the local y-axis. This is a very crucial information. Let's look at where STAAD is obtaining this from. You know, the importance of engineering design is that you understand the principles behind your analysis. If you don't understand the principles, you will be doing a wrong engineering structural design. Let's look at where it's getting this from. Now, in the British Standard Code of Practice, it says that now the slenderness ratio is the effective unbraced length between point of support braced against lateral torsional buckling. So if you're designing short or slender columns, the slenderness ratio is a function of the end restraint of the column at the bottom or at the top. So if you go to table 3.19 of the Code of Practice, it tells you that the end condition is if it's 1, 2, or 3 at the top, or 1, 2, or 3 at the bottom, the corresponding effective length factor is obtained from this code. Let's look at what these conditions are: 1, 2, and 3. So it explains conditions 1, condition 2, condition 3, and condition 4 carefully in section 3.8162. Okay, so if you look at condition 1, for example, it tells you that if the end of the column is connected monolithically to beams on either side, that's either at the bottom or at the top, which are at least as deep as the overall dimension of the column in the plane considered. So if it is connected to beams which are of the same dimension of the column or is deeper than the column in the plane of bending considered. So if you are considering the bending in this direction, we have to be very specific. Let's look at this in a very detailed. Let's just look at this. So what it is saying here is, if the column, look at this column, this is a 225, this is a 230 by 230 column. It's saying that if you are considering bending in this direction, okay? Sure. So in this direction, the dimension that pertains to this direction of bending is 230. It says if the column that is if the beam is connected to is as deep, is at least, look at the English, the nomenclature is crucial. So if the columns is connected monolithically to beams on either side which are at least as deep as the overall dimension of the column in the plane considered. So this beam, this is a what this thing is that now. So this is let's look at that. Okay, this is first floor. So first floor is about so 230 by 450. So it's about 230 by 450. So the columns, or rather the beams, is deeper than the column in the plane of bending considered. So if you look at it now, it's deeper. So it means that the condition at the bottom and also the condition at the top, because it's also deeper, it's the same 230 by 450 on the second floor. So if that is the case, it means that the condition that pertains to the code there is condition 1. So if the condition at the bottom is condition 1, or sorry, at the top, so it's telling you that this is the effective length coefficient factors for braced columns. See, it says that the effective length for short columns is calculated based on the effective length coefficient. So the effective length is the effective length coefficient times the length of the column. And this effective length coefficient is a function of the end restraint of the columns at the top or bottom. So at the top, you check the condition at the top, you check the